All right, today we're doing section 3.1. Our objective is to solve a system of equations by graphing. A system of equations is a set of two or more equations that use the same variables. A brace is used to keep the equations of a system together, so like the curly brackets. There are several ways to solve a system of equations. If both the equations are linear, then the system can be solved by graphing and finding the intersection point of the two lines. You can pause the video here if you need more time to write that down. A system can also be classified by the number of solutions it has. An independent system has one unique solution. A dependent system has no unique solutions, meaning there are an infinite number of solutions. When graphed, the lines lie on top of one another, so it looks like there's just one line there. An inconsistent system has no solution. When graphed, the lines do not intersect. They don't touch, or you can remember that they are parallel lines. All right, so let's practice solving these by graphing. So we're going to graph both lines and look for where they intersect. To graph y equals negative 2x plus 7. This is in slope-intercept form. Y equals mx plus b. So on this one, our y-intercept is 7. So we go up to 7 and put a point on our y-axis. Then we use our slope as negative 2 or negative 2 over 1 to get more points. So negative 2 over 1 means we go down 2 to the right 1, down 2, right 1. And we can keep doing that to get more and more points on our graph. Instead of going down 2 to the right 1, we could go up 2 to the left 1, and that'll be on the same line. Then we need to use a straight edge to make our line through our graph. To graph the next equation, we have y equals x minus 2. That means our y-intercept is at negative 2, and our slope is 1. So we'll go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. We keep doing that to get more and more points. And again, we make our line using a straight edge. Once we have both lines graphed, what we're looking for is where those two lines cross each other. We can see that happens right here. We just need to identify that point. So the coordinates of that point would be 3, 1. And that is our solution. That's our answer. So graph both lines, figure out where they cross each other. On number 2, the first thing we need to do is put them into slope-intercept form. We want them to look like y equals mx plus b so that we can graph them easier. On these, it's not too bad. We're going to have to subtract 2x from both sides on the first equation to get y equals negative 2x plus 5. And we'll have to add x on the second equation, giving us y equals x plus 2. And we graph them just like before. So we go up to positive 5 for our y-intercept of 5 and put a point. Negative 2, we treat our slope as negative 2 over 1. So we go down 2 to the right 1. We do that to get more and more points. Or we can go up 2 to the left 1. We use a straight edge to make our line. And then we graph our second equation. So to graph our second equation, we go up 2. And then our slope is 1 over 1. So we go up 1 over 1, up 1 over 1, up 1 to the right 1. As many times as we need to be able to get that line and make sure that our lines cross each other. Now they cross each other at this point. So that point is at 1, 3. 1, 3. That is our answer. We can check our solutions by plugging these back in. We know if we take 1 plus 2, we get 3, so that works. And if we take -2 times 1, that's -2 plus 5 is 3, so again, it works. On our third problem, these ones are already in slope-intercept form, so we'll just jump right into graphing them. First one, we go up 2 on our y-axis, and then we use our slope of 3/1 to plot our points. And we put in our line. Okay. Let's do that again. That's a little better. All right. Then we go to graph our second equation. Our y-intercept is -1. Our slope again is 3/1. So these lines are very close together, but hopefully we can see that they don't touch each other, and they're not going to. If two lines do not intersect, they don't touch ever at all, they are parallel, then there is no solution. All right, on this one, let's first work on getting the second equation into slope-intercept form. So we add 4x to both sides. That gives us 2y equals 4x plus 6, and then we divide everything by 2. That gives us y equals 2x plus 3. Now you'll notice that our equations are exactly the same. Same equation twice. We can still graph it. We go up to 3, and then we go up 2/1 using our slope. And we can make a line. But if we graph this, it'll be the same exact line. We'll just make it twice. So we can do it in another color if you want to. But then that line will be exactly the same. When that happens, you have two of the exact same line, that's when we have infinitely many solutions. If the lines are exactly the same, there are infinitely many solutions, and that's our answer. There's no point, there's no single point. There are infinitely many points that we could pull out that would work for those equations. For our last example, okay, I'm going to rearrange these first. For our first one, we would have -y equals -4x plus 6. So we switch all the signs. Y equals 4x minus 6. Means I go down to -6. And then we go up 4/1. Up 4/1. Remember, these equations are in y equals mx plus b, where b is our y-intercept and m is our slope. So I can graph that line. Arrows on the ends. All right, I'm going to erase that so that I can then find the equation of my other line in slope-intercept form. On this one, I would have to add 2x to both sides, and then divide everything by 3. That gives me y equals 2/3 x plus 4. So I go up to a positive 4, put a point on my y-axis. Then I need to go up 2/3, up 2 over to the right 3. And that gives me my second line. Make sure you're drawing your lines long enough so that they do end up crossing each other. And we find the point of intersection is right here. So that is at the point 3 6. 3, 6. And that is the answer on that one. So that wraps up the notes and examples for this section. If any of that was too quick or you have questions, just go back and rewatch it, slow it down, one step at a time, or ask questions. All right.